Okay, in this video, I want us to take a look at how lines are really put together. Something we probably haven't thought about enough, but sometimes you're asked to graph equations like this: y equals x plus 2. Right, now we've all learned how to break these down and graph by slope. So you could just graph this line directly, but let me show you how it's actually put together. We actually have two different lines that are being added together. One of those lines is y equals x, okay, and the other line is y equals 2. So let's graph these two lines and see what I mean by adding them together visually. So first I'll graph y equals x. Okay. Just want to make sure I'm going to have it pass through all the right points. Okay, so there's the line y equals x. And now let's graph the line y equals 2. Okay, that's just a horizontal line passing through 2 on the y-axis because it has a slope of 0. Okay, so there's our two lines. This is y equals 2. Well, like I said, I want us to find out what would happen if we were to add these two lines together. So what do I mean by adding two lines together? Well, what I mean is, let's check what these y values are at different x values. So let me write in my x values here: 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And let's put in our y values: 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. Okay? And we also have the origin point 0, 0. So let's start at the origin. So what I'm going to do is I'm going to say at x equals 0, I'm going to put a circle around where my lines are. So I've got there two dots. One of them is 0 on the y-axis, and one of them is 2 on the y-axis. So let's just add those y values. 0 plus 2, what's that? Well, that's 2. So one of the points on my new line, x plus 2, is at 0, 2. Well, now let's check x equals 1. Okay, so at x equals 1, I have my y equals x line passing through that point. On the y-axis is 1. And then at x equals 1, my other line is passing through 2. So let's just add 1 plus 2. What's 1 plus 2? It's 3. Okay, let's try one over here. Here at x equals 4, I have my line y equals 2 passing through 2. And then I also have my y equals x line passing through y equals 4, right there. So I'm looking for the y values at different x values. Now let's add these two together. Okay, so 2 plus 4 is 6. Well, that would be this point right here, 6. Now let's try some negative values. Let's try -5. Okay, so at -5, at x equals -5, I have one y value here at 2, and I have another y value here at -5. So what is 2 plus -5? Well, that's -3. So there's a point right there. Now let me use my red pencil here to graph in this new line, all these different points that I've plotted. Just try to make sure they're all going to go through the proper points. This is a pencil that is kind of fat. I got to be careful about it. Okay, there we go. So this is the line y equals x plus 2. And now you see visually how we came up with this line by simply adding together these two equations. You can do this for any pair of any equation can be broken down like this. You've got a linear term here and a constant term here. So we could do the same thing if we had a quadratic equation or cubic or any other polynomial. It could be broken down like this. And you could graph each individual part of the line, right? Because this is basically what I did. I had y equals x plus 2, and I just took them in pieces. I had y equals x, and then I had y equals positive 2. I graphed both of those lines and then added together their y values for different x values and produced a brand new line, this red line, y equals x plus 2. So I hope you learned something from that and found it helpful. Thanks.